49 group anagrams. Given an array of strings, group the anagrams together. You can return the answer in any order. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So as you can see in this example, a list of strings are given to me, and I should check every single one of them and see if they have the same letters or they are anagram, right? In another word, if they're anagram, and then I group them together. So bat is the only word that we have. Nat and tan are the anagram because they both have A and T, and ate, eat, and T are anagrams, and they are grouped together because all of the three have A, E, T as the letters that has made them. And if the list is empty, we are going to return an empty list, and if you have only one word, we are going to return that. How are we going to solve this problem? The plan of attack is going to be we need a data structure that we can use the letters that we have in here as the key and these strings as the value, right? How can we do that? What data structure has that? Hash map. And why hash map? Because hash map and the hash map time complexity for finding an item is going to be constant, and it's the best case. So we are going to use a hash map, and what are we going to have as a key? The letters of a string, the letters are going to be the key, and the value is going to be list of strings with the same key, right? And then what we need to do, we need to iterate over this list at least once to find the key and see if it is in the hash map, and if it is, we are going to add it into the list, and if it is not in the list, we create the key and then we add that string as a value to that string, to that key. So we are going to iterate over the list, right? And check the string in the hash map, right? And finally, what we are going to do, we are going to return the hash map's values as a result. So let's see how can we do that, how we can do that. So hash map is equal to, what are we going to do? We are going to have a key and we are going to have a list as the value. How can we do that? We can do it with collections library. So for collections dot default dictionary, we are going to add a list here because we want to make sure that the values are going to be as a list. And then for the step 2, we are going to start iterating over the list of the strings that we have. STRs that is given to us here, which is the list of strings. Then this is the most important part. I'm going to define the keys. How am I going to define the keys? I'm going to have a list of zeros, 26, right? Why 26? Because the alphabet is 26. And then I'm going to say for every single character that I have in this string that I just got from the list, for character in a string, what I'm going to do, I need to build my key. How am I building my key? I get the index for that character and I will add 1 to it. So how can I get the index? I'm going to use ORT function. I will use the ORT function. I put the character in it and I minus ORT. The A is the base case that I'm going to use, right? Plus 1. I'm going to add 1 to it. So what will happen to it? So let's say we have E, we find the index E, and we add 1 to it. We have A, we find index for A and we add 1 to it. And if we have T, we find index T and we add 1 to it. If we had, like, for example, 2T, for the index T, we had number 2 there. So what is happening? So if the letter is A minus A is going to be 0. So it starts with index 0 and it goes all the way to 25, which is going to be 26 characters. And after getting that, so what I'm going to do, I'm going to add this key to my hash map, and I'm going to append, because the value is going to be a list, append and a string to the list of this key. But we need to do something here because we cannot pass a list as a key to hash map. What I need to do, I need to make it as a tuple, right? Because of the constraint that we have for the key format, we need to make it as a tuple because the like dictionary accept tuple as the key. And then after we are done with this should be here. After we are done with this, we are going to return the hash map dot values. So this is going to be the result. So I'm going to review this. So we make a dictionary, which is going to be keys and list. And then we start from the first string and we go all the way to the end. So the time complexity for this is going to be, if the length of this list is n and the length of the like each letter is m, so the time complexity is going to be n by m. And the space complexity is going to be equal to the length of the like string that we have, which is going to be n. And so it's complaining about this. Let's just remove this. And there is an indentation problem here. Sorry, my bad. And then around this, there we go. So let me just print out the hash map here so you can see how it will look like, the hash map. You can see that, see, the key is a list of 26, right? You see this is a list of 26 characters, and at each index we have like a value which indicates how many of that character that we have in the list. And thank you.